task for them. Okay, and in fact, actually, what attackers do nowadays is that they maintain this database, pre-indexed. They keep on crawling and can maintain this database and in some raw big data tables, big data solutions, so that whenever a vulnerability comes up, they can go and just do a search on this and find a potential target. Right. So first step is internet-wide scan and index it into the database so that you can search later. Then the next step is to use a deep crawler. Now, what this crawler does actually is for different products. It goes and crawl and do a fingerprinting of the service. The reason, and then detect technology, its versions, etc. The reason for this is it makes easy to map a CVE to a technology to a target. Right? For example, if again ESXi server, if I take, I can go and scan the IPs. I can grab the banners. I can do fingerprinting that this specific technology, which is VMware, a specific version. I can write parser to extract the versions and the technology on it, and I can keep it indexed actually, or even we can use it as on demand. In fact, whenever vulnerability comes, we can go and scan the internet, scan the IPs. So once this crawling is done, the next step is CV identification, which means that once a vulnerability is vulnerability is published, it's matter of within maybe a few minutes to find out or maybe an hour to find out what versions are really impacted, which technology is really impacted. And once it is identified, we can make a query into this database to find out which all targets are potentially vulnerable, right? And once this vulnerability identification is done on these potential targets, the next step is to try out the exploits. And generally, these exploits, once run, as I said, the vulnerabilities are those specific vulnerabilities which can give remote code execution most of the time to the attacker. And these are the vulnerabilities which are being targeted by ransomwares. So this is the the flow that automation that has allowed attackers to automate this whole mass scale scanning and attacking within few days, in fact, and which actually the point that I was referring to, that the mean time to remediate a vulnerability has reduced to even few days. Now, in summary, mitigating external critical CVEs could reduce ransomwares by 26%, I think, right? As per the stats, as per the the research by various reports, right? But the catch is that your MTTR has to be few days. If it is not done, if the vulnerability is left open more than few days, then there is an increasing chance that it can be potential target of an attacker. And it is just luck that it is not being exploited. But then, if it is done correctly and there is a practice that continuously, have these vulnerabilities and mitigate them on within few days, then yes, we can actually reduce the ransomware risk by 26%. Now the question is how. Now, before going to details on how, I just want to talk about FireCompass. So FireCompass research team, and I want to just give a background about ourselves. FireCompass research team, by the way, track brand new latest CVEs on continuous basis. Like whenever a new vulnerability is added to the NVD database, we go and track it, we go and analyze it. And then we help our customers to identify exposure to these CVEs within a day, so that customers can take action and mitigate risk of these CVEs using appropriate security measures. Now we have prioritized the upcoming, we will talk about certain CVEs And then we have sent in alerts, exposure alerts to our customers that will reduce the risk ransomware at least by 25-26%, assuming you have already fixed critical historical other critical CVEs. So assuming that other CVEs which are already being fixed, the new CVEs that we will discuss right now, if those are fixed, then your chance of risk of ransomware will be reduced by 26%.